So we've just completed the method section, and now we're going to move on to the results section. Now, every epidemiologist, as they become more and more experienced, develops their own style of how they approach the results section and reading journal articles in particular. But what I want to talk about is the way that I personally approach reading the results section as an epidemiologist. And I'll talk about why I want to use that approach, and then I'll explain some other approaches that individuals do. So some people will, go through and read the results section in detail. In contrast, I don't necessarily take that approach, at least to start off. What I usually do is skip the results section, at least initially, and I move directly into looking at the tables. And so the first table is table 1, so which I'm just going to put up here for right now. The reason I like to look at the tables and skip the results section is because I actually like to take a look at what the data are showing me, and I like to personally interpret those values and come to my own conclusion without having the author tell me what their numbers say. And so after I review each of the tables, then what I do is I go back to the results section, the prose part, what is written in words, and I'll actually skim it. And the purpose of skimming it after I've read the results, or read each of the tables, is because I want to make sure that the authors give a fair representation of what the data are actually showing. The other reason I skim the results section, the prose part, is to see if there were any other results that were, or analyses and results that were presented as part of the prose that weren't necessarily presented as a standalone table. So I personally go with reading the tables, analyzing the data myself, coming to my own conclusions, and then reading what the authors have to say. And that way, that allows me to come to my own conclusion without depending and relying on what the author's conclusion is. Other epidemiologists may take a different approach. They may skim the results, and as they're skimming the results, if you can see here, this first paragraph has a lot to do with table 1. So an epidemiologist might really briefly skim that prose part and then take a look at the table 1 in depth. Then that person might go back to the prose part and see how the second part here is associated with table 2, or it's talking about table 2. The author might then go back to the table, read table 2 in depth, and then come back. Other epidemiologists will literally skim the entire prose section first and then go to the tables. Neither of the 3 scenarios that I just presented, neither scenario, one is right or one is wrong. It really just is dependent upon what approach that you works for you. So, since I'm the supposedly the expert, today I'm going to show you my approach, and that is we're going to skip the results section and we're going to go directly into the tables, and then we'll come back to this prose part. So what we have here is table 1, and you can see the first thing that I always do is actually read what table 1 is actually going to tell me, what is the information that's being presented in table 1. And so what I do is I read the table, baseline characteristics of participants according to frequency of fried food consumption in NHS and HPFS. And so this is essentially telling us descriptive information about the participants who are included in this sample. And there's a couple of reasons why giving us this descriptive information is incredibly important. Oftentimes, remember, in epidemiology, we rely on observational studies. We don't have these gold standard randomized control trials, and so with observational studies, we know that typically people who behave a certain way, for example, who consume a lot of fried food, are often inherently different than people who don't consume a lot of fried food. And so what we want to do is, we're looking at fried food consumption by categories and their frequency. We want to see how those people who are put in those different categories, how they differ on a number of other characteristics, including, if you can see here, some basic socio-demographic factors like age, race, marital status. It also provides other information besides socio-demographic information, including your medical history, or your health history, such as high cholesterol, family history of diabetes, hypertension, smoking, and also, finally, it also tells us some information about dietary intake. Yes, of course, our exposure of interest here is fried food consumption, or frequency of fried food consumption. What we're trying to establish, well, do other aspects of their diet differ between those who consume a lot of fried food and those who don't? Are there other aspects of their diet that may differ between each of these groups? So that's kind of the purpose and rationale of understanding why descriptive characteristics are almost always presented as a table 1. In this particular table, just so you can kind of understand how the table is organized, you can see at the top part here, data are presented for the nurses' health study, and then if you look below here, all of this data is for the health professionals follow-up study. And so again, all of it is descriptive information. Okay, so I'll just point out a few important things that I noticed while I'm looking at this table. One of the first things that I immediately try to understand is the sample size. And that is marked by the word N, and if I go across at the top, it tells me the number of individuals that consumed, for example, 35,594 individuals in the nurses' health study reported consuming less than one, they consumed fried food less than 1 time per week, versus 2,481 women reported consuming fried food more than 7 or more times per week. And so part of the reason that I look at the sample size, yes, when I was looking at the method section, we had an understanding of the overall sample size, but part of the reason that I look at the sample size here now is because I want to see how many people are in each of these groups. And that becomes incredibly important when we start thinking about power later on. Typically, if one of these categories, let's say your high frequency category, had very, very few people in it, then it may lead to low power, which means that we would not be able to really detect an association if one really exists. Okay. So we're going to continue on just some important things that I noticed. For example, if I look here across these 3 particular variables, age, BMI, and physical activity, what I notice is that there seems to be some differences by age according to frequency of fried food consumption. So those who consume less fried food consumption were a little bit older than those who were consumed more than 7 or more times per week. In terms of BMI, what we notice here, those who consumed had fried food consumption less than 1 time per week, they tended to have a lower BMI than those who consumed it 7 or more times per week. There were also differences in physical activity by frequency of fried food consumption, with those who consumed less frequently being more physically active than those who reported more frequent consumption. Okay, some other things that I noticed, I'll give you an example. I told you that this data where they have socio-demographic information, but they also have some family history, medical history involved data as well. And so what I'm just going to point out here, for example, is hypertension. And so if I look here, 20.3% of those who had reported consuming fried food less than once per week, 20.3% had hypertension. If I go across, seems to decrease, but then all of a sudden, by the time I get to the last category, it seems to pick up again in its percentage. So there doesn't seem to be as clear of a trend. All right, and as I said here's some more medical history, and you can go through and go by each variable and come to your own conclusion whether individuals who consume the amount of times that you consume fried food per week, do they differ in some of these other health questions? The last particular category that's particularly interesting to me as a nutrition epidemiologist is some nutrition data. And so here, what the authors are saying is, yes, we know that people who consume fried food frequently are probably going to have a different diet than those who consume fried food infrequently. And so this is actually just essentially giving us data or evidence to support that general assumption. And so if you just look here, if you look at total energy, those who reported consuming less fried food had a lower caloric intake than those who consumed more fried food. They were more likely to have a higher amount of fruits and vegetable consumption than those who ate fried food infrequently. Red meat consumption also differed between these groups. You can see as I'm going across fried food consumption frequency, you can see red meat frequency goes up. A couple of interesting things. At this point, there are going to be some other dietary differences. I'm just selecting a few characteristics to point out. Again, you should go through and identify each of these variables that they're doing, that they present. Just doing it in the interest of time and selecting a few. There's a couple of interesting things. What I just showed you here is it looks like the amount of red meat consumption, or the number of servings of red meat consumption per day, increases with the number of times you eat fried food per week. So 0.9 over here, 1.7 over here. What's really interesting about this particular table is that this particular table suggests that there is this increase across these different categories, but there is no statistical testing to identify if 0.9 servings is actually statistically and meaningfully or statistically different than 1.7 servings per week. This is a little bit peculiar. Most descriptive studies, descriptive tables have some sort of statistical testing, but in this particular table there is no statistical testing of this. These data suggest that, but without having any sort of statistical testing, we don't know that for sure. Okay, just to move on to the bottom part, as I said earlier, the data that I presented, that's presented at the top, is from the Nurses' Health Study. The data at the bottom is from the Harvard Health Professional Follow-Up Study. Again, it's all the exact same information that was presented for the Nurses' Health Study. It's just now for the male population. So I'll let you look at that on your own, and we will move on to Table 2. So this is Table 2, and the first time I saw this particular table, I could imagine that most of you would be pretty overwhelmed by the amount of information that was presented on this particular table. This particular table, if you're from a nutrition epidemiology standpoint, this is actually pretty standard of what you might observe. There's a lot of data and there's a lot of models, and so the first thing that I like to do is just try to orient myself to what am I actually looking at. And so again, I'm looking at the table. It says RR, which it stands for rate ratios, and 95% confidence intervals for type 2 diabetes in the two different samples according to fried food consumption. Essentially what the authors are doing here is examining what is the relationship between fried food consumption and my outcome, and in this particular case, for Table 2, they're looking at type 2 diabetes. Now again, there's a lot of information going on, but I think it's important to just orient yourself to how the table is organized. You can see it's divided into 3 different sections. The first part 1, that all of that information pertains to the Nurses' Health Study. Part 2, all of that data comes from the Harvard Health Professionals Follow-Up Study. And Part 3 is all of the data combined together. It didn't matter whether you came from the Nurses' Health Studies or the Health Professional Follow-Up Study. So once you've organized yourself to the different samples, then you can stick to one sample at a time. what you have here on the left, now you can figure out that the data are separated by not just fried food consumption, but where you consumed that fried food. So at the top they said, okay, we don't really care where you consume that fried food at all. We just want to know total amount of fried food per week. This second category is fried food at home. Third category is fried food away from home. And again, this is repeated in each of the sections. Now, as you move across, you can see it's separated by the frequency of fried food consumption, how often you consume it. Okay, so now that we're organized to the table, now actually let's take a look at what the heck this particular information is trying to convey to us. So before we look at this table, which has a lot of information going on, I think it's just important to just remember what the point of this analysis was to do. So the authors are interested in examining some relationship between exposure and your outcome. And in this particular case, it's fried food consumption. Fried food consumption. And the outcome is either type 2 diabetes or coronary heart disease. And so that is the main analyses that the authors are interested in focusing on. The problem is that if they just looked at this relationship without accounting for other variables, they could come to potentially the wrong conclusion. And what I mean by that is, remember that in a lot of epidemiologic studies, we mostly rely on observational studies. People aren't randomly randomized into different groups. We don't say you can have lots of fried food and you can't have any fried food. And because we observe people, we know those who are consuming fried food, higher amounts of fried food consumption are inherently different than those who do not consume a lot of fried food. And that actually was supported by information from Table 1. And because of that, we know there are these other variables what we call confounders that are associated with both the exposure and the outcome. And because we know those other variables are associated with both the outcome, the exposure and the outcome, if we don't account for the influence of those confounders, we can actually come to the wrong conclusion. And so what the authors are actually doing in this very, very complicated table is to actually build a series of models where they say, okay, we're going to examine the relationship between fried food consumption and the outcome, in this particular case, type 2 diabetes, while accounting for these other variables. And so what they do is they develop several models. Model 1, they adjust for a lot of sociodemographic factors, including age, race, a few health history questions, including family history of diabetes, their smoking status, alcohol use, physical activity, and menopausal status if it applies. Okay. And what Model 2 they do is they say, okay, again, these are some variables that we think are associated, maybe above and beyond these sociodemographic and health behavior characteristics. And what we're saying is, yes, what we just established, people who eat diets that are high in fried food probably have other characteristics of their diet that are different than those who don't eat a lot of fried food. So what they, in Model 2, what the authors do is they adjust for all of the confounders that they identified in Model 1, and they also adjusted for total energy intake, or the amount of total calories that each of these individuals consumed, and their diet quality. And so that is what is represented in Model 1 and Model 2. Now you can see they also have something called Model 3 and Model 4, and what those models actually represent is they say, okay, well, here are these variables that we know might be associated with both the exposure and the outcome, but the authors are also wondering the question, beyond, if there is an association between exposure and the outcome, in this case fried food consumption and type 2 diabetes, is this relationship also partially explained by its relationship to other variables? And what I mean by that in this case is a mediator instead of a confounder. And so what I mean by this now is in Model 3, the authors adjust for for whatever they adjusted for in Model 2, plus hypercholesterolemia, and hypertension. And so what the authors are asking the question, okay, if there is a relationship between fried food consumption and type 2 diabetes, even after you control for all of these confounders, is this relationship due to the fact that those who eat fried food are probably going to have high cholesterol and high blood pressure? And is that really what is explaining the relationship to type 2 diabetes? So those who eat more fried food, they're more likely to have high lipids and high blood pressure, and therefore those who have high blood pressure and high cholesterol, they're more likely to develop type 2 or coronary heart disease. So does that explain that potential relationship? Model 4 is everything that's in Model 3 plus BMI, or weight status. Another way to think about this last concept of mediators, if that wasn't clear to you, is are these factors, hypercholesterolemia and hypertension, or your BMI status, on the causal pathway between fried food consumption and the outcome of interest? All right. So now that we understand this stair-step modeling approach that the authors used, we can actually now start investigating the numbers and start analyzing what these numbers mean. Okay, so a few more things. First thing, RR. What this data is telling us, what is presented in this table, is an RR. That represents what is called a rate ratio. We are trying to establish what is the rate of the outcome in this group relative to some other group in this particular case. What is the rate of type 2 diabetes among those who consume it 1 to 3 times per week relative to those who consume fried food less than 1 time per week. And so it's a comparison of the frequency of the outcome between these two groups. Now, there's a lot of information presented in rate ratio. When we see a value greater than 1, that indicates that there is a positive association between fried food consumption and type 2 diabetes. In other words, the more fried food I eat, the greater chance I'm likely to develop type 2 diabetes. If I see a value that's less than 1, when I'm looking at some sort of ratio value, that indicates that there is an inverse or negative association between my exposure and outcome. That would suggest, if we're seeing a value less than 1, the more fried food consumption or fried food I consume, the less I am likely to develop type 2 diabetes. Now, if I just look at this table, all of these values are greater than 1, so I know that the higher consumption generally suggests higher risk of type 2 diabetes. Now, there's one other point with respect to understanding rate ratios. If I have a value that's equal to 1, that indicates, that's also referred to as the null value, and that indicates that there is no relationship between exposure and outcome. Okay, so now that we understand what a rate ratio is, we're actually going to give an example of a rate ratio. So let's go across here. We're going to just focus on the Nurses' Health Study and the total fried food as an example. If I come all the way over here, as an example, the rate ratio is 1.70. What that means is those who consume 7 or more fried food 7 or more times per week are 1.7 times more likely to develop type 2 diabetes than those who consume less than fried food less than once per week. Okay, so that's what that means, this little 1.70. The other thing that I wanted to point out to you at this point is what these numbers in the parentheses represent. And so as you're looking here, all of these rate ratios have some sort of confidence interval next to them. And that's what is indicated in the parentheses. What a confidence interval is, in its most simplistic sort of definition, it measures the precision around your rate ratio. How precise is your rate ratio measured? And precision is influenced by a number of factors, including the variability around the mean value. It also reflects power issues. As the semester goes along, we'll talk about all of the factors that influence confidence intervals. But at this point, when you are interpreting your confidence interval, what epidemiologists primarily look for is, does it contain the null value? And remember, I said that the rate ratio of null value is 1, which would mean that there is no association between the exposure and the outcome. Now, when I'm looking at this particular confidence interval, it does not span the number 1, so it goes from 1.5 to 1.94, and what that means, that confidence interval does not contain the null value. So what that also indicates to me is this 1.70 rate ratio is statistically significantly different than 1, which means that I know these people who consume fried food 7 times or more per week are significantly more likely to develop type 2 diabetes than those who consume less than 1 time per week. Now take that value, 1.70, and contrast that to what we observed in this last model 4. So model 4 is right there. You can see that the rate ratio is 1.09, and you can see that the confidence interval spans from 0.96 to 1.25. Now, 1 is in the middle of those two numbers, so I know that the null value is included in that confidence interval. And so what this tells me is that 1.09 is not statistically significantly different than 1, which means that by model 4, those who consume fried food 7 times or more per week are not statistically different. Their rate of developing type 2 diabetes is not different than those who consume it less than once per week. Okay. The last thing that I wanted to point out to you on this table before we actually interpret some of these data in a meaningful way is what this P for trend means. What that particular statistical test does is examine the relationship between fried food consumption and the frequency of it with type 2 diabetes, but it examines it with respect to the frequency and dose response of fried food consumption. In other words, what I'm saying is, if we consume more fried food, we see, as we consume more and more fried food, we'd expect that rate of type 2 diabetes to go up. And so if we look across at this model 1, you can see that the p-value is less than 0.05, which suggests that there is a significant linear relationship. If you look at this value here, and what I mean by that is, if I look at this value here, those who consume it 1 to 3 times per week had an increased risk of rate of 1.14. As you consume 4 to 6 times per week, that rate ratio goes up, and that goes up, now it's at 1.55, and by the time you get to that highest category, it is now at 1.70. In other words, the more you eat fried food, the greater your rate is of developing type 2 diabetes. And that's what a P for trend tells us. Okay, so now we're actually going to interpret some of these results. There's obviously a lot of results going on this particular table. I'm just going to highlight a few of the major results. one of the things that I particularly noticed, I happen to focus a lot on differences between fried food at home versus fried food away from home. And part of the reason I chose to focus on that comparison is because in the background or the introduction of the paper, the authors presented a lot of biologic plausibility or rationale why eating fried food at home would be different than consuming fried food away from home. And so since they were pointing out all of those differences, that was one of the comparisons that I wanted to make. And so what I noticed here is that overall many of these results are significant, okay? And I can tell that by, all of the confidence intervals. There's a lot of significant findings. But what I found was that the relationship between fried food consumption at home and with type 2 diabetes was slightly different than the relationship between fried food consumption away from home. And the reason that I can tell that is if I look at these values here, and I compare that to those values here, I can see that the strength of the relationship or the magnitude of these numbers is farther and farther away from 1. So it tells me that the relationship between eating fried food away from home with type 2 diabetes is stronger than the relationship than eating it at home. That conclusion that I came to is also supported by one additional piece of information, and that's when I look within a particular, I'll focus on this particular category right here. This is fried food consumption at home. What we can see is when we adjust for these socio-demographic factors and health behaviors, current ones, we see that there is this relationship. So you can see that those rate ratios are statistically significant in Model 1 and Model 2. So there is a relationship between fried food consumption and type 2 diabetes while adjusting for these potential confounders. But once you ask the question, well, does that relationship still exist if we account for hypercholesterolemia and hypertension and your BMI status? That association seems to go away in much of the data presented from home. So you can see here. That association was attenuated there. Versus in the fried food away from home, that association remained constant. So overall, there seems to be a lot of relationship, a strong relationship between fried food consumption and development of type 2 diabetes. There are some interesting differences between fried food at home and fried food away from home, with a stronger relationship being observed for away from home. Again, there's more data for health professional follow-up study. Much of those findings are exactly consistent with nurses' health studies, so I won't go ahead and present them. And then obviously, they pooled all of those results together, so you would expect to observe probably somewhere in between both of those results. So now we're finally moving on to Table 3. Table 3 is very, very similar to Table 2. The major difference is that instead of looking at the relationship between fried food consumption and type 2 diabetes, Table 3 is now focused on the relationship between fried food consumption and the outcome here is coronary heart disease. The table is organized in the exact same way. So here's the nurses' health study presented at the top. Then we have the health professional studies, or the Harvard Health Professional Follow-Up Study, and then they pool all the results towards the bottom. There's just, what I would suggest doing at this point is to examine the results with a critical eye, the exact same way that I just did, paying attention to the actual value of the rate ratio, looking at the confidence interval to see if that rate ratio, if the confidence interval contained the null value, to examine some of these p-values for the pre-for-trend statistical test. Once I've done that, what I would do is to tried to come to some major comparisons between what the results are for type 2 diabetes and coronary heart disease. And so for that, I'm just going to bring up table 2 really quickly again. So on the left-hand side, I have my results for type 2 diabetes. On the right-hand side here, I have coronary heart disease. Okay, and so what I'm focused on now are these two lines right here. These two lines right here. Okay. Some important things comparisons that I notice. I'm going to compare these two groups here. Okay, and what I've just circled is the Nurses Health Study fried food at home model and the fried food away from home model. And what I notice, this is the type 2 information. What I notice is the magnitude or the numeric value of these rate ratios here in the type 2 data are stronger than, or higher, or further away from the null value 1 than with coronary heart disease results. And so again, just to sort of point this out, let's take a look at this top value. Model 1 in the fried food away from home model, looking at its relationship with type 2 diabetes, the rate ratio was 2.22. So those who consumed fried food more than 4 times per week or 2 times had a rate of diabetes 2 times higher than those who consumed it less than 1 time per week. But if I go over into the coronary heart disease, that rate ratio is 1.44. And what I notice is that value contains the null value, that confidence interval contains the null value. So while it suggests a positive relationship, it's not statistically significant. So after I interpret all this data, and I look at, I'm going back to just the coronary heart disease table, if I'm looking at the overall general numeric values of table 3 alone, there are a lot of positive results suggesting that the more fried food I consume, the greater risk or rate I have for the development of coronary heart disease, but that does not seem to be as strong as the relationship with fried food consumption and type 2 diabetes. All right, so again, there's more data. You should go through and look at each of these numeric values and make sure you understand the different models and the interpretation with each of the values there, but I pointed out the major comparisons that I was interested in.